The topic is about the embedded software. Why this embedded software is required for the devices. So mainly, the embedded software plays a crucial role in the functionality of many modern devices and the system. It's specially designed to run the embedded system and the computer built to be specific task. So this is important for the embedded software. Uh, from the we are able to optimize the performance. We are able to manage the hardware resources efficiently, and we are able to perform the reliability and security of the system that can be operated with the help of this embedded software. So to understand in detail about embedded software, the agenda, like we need to understand about the introduction of embedded software and the components of embedded software, and programming language is required to develop the embedded software, and the development tools, what are the development tools required. And so the software, it will be characterized into the RTOS and the non-RTOS, so the non-real-time operating systems. Introduction of embedded system software. So for every embedded component, the embedded software is required to read the input variables and to vary the output variables, and even the hardware which have specifically designed to perform specific tasks. So whatever the modern devices we have, it will be configured with the embedded software to specifically to run the inputs and outputs on different conditions. So it are interlinked with other devices and the tools and the communication protocols, and specifically we develop the software and to run some information on the controllers. And here, uh, each and every device, it has specifically programmed in such a way to operate in different conditions. So it should have a memory. So and it have the processor to process the data, and it requires some battery powerage to supply the power to the entire resources, the inputs or the outputs, to operate in different conditions. And the hardware, like equipped with different areas like automotive issues or IoT devices or medical equipments or agriculture equipments and the consumer electronics. Every hardware device requires the software, and it should be categorized as the RTOS, real-time operating system, and non-real-time operating system. And the on top of that, the application software will be added. So just to understand the components of embedded system software, so here we have the real hardware, the CPU, and the firmware related to the Wi-Fi, and firmware related to the CPU, firmware related to the Bluetooth. So that will be added towards the hardware junction. And on top of that, we have the operating system, the OS, and the application software will be added. And to work this application software on the top of the hardware, so it requires the drivers. So and some part of low-level software that is directly interacted with the hardware. So like the drivers here, Wi-Fi drivers or Bluetooth drivers, it requires firmware. So that are configured with respect to the drivers. So it will be the low-level software that is directly interacting with the hardware. So this is the first component. And the second component will be the drivers. So once the software is ready for the Bluetooth or Wi-Fi, so it will be accessed towards the drivers. So it will facilitate the communication between the hardware and software layers. Like we have the application software here, and we have a drivers to communicate, and we have the hardware controller, and we have the devices, the real hardware. So whenever the OS is here, the boot OS. So whenever the device is enabled, so that time this will be boot will be activated. On top of that, the device drivers will be activated, and then the communication will be established on the bus drivers. And the other part of component is the OS operating system. So this is it have two categories. One is RTOS, real-time operating system. It will manage the task with the scheduled time on the based upon the requirement. A non-RTOS, it is a simple system without any time constraints. So these are very important on scheduling the task with respect to the time constraints and components of embedded system. So the application layer, so whatever the program we are able to write, so that will be the high level software we are implementing to specific functions that is required. And component of the embedded system the embedded software requires is the bootloader. So where the boot will be the first phase, so that will initialize the hardware and the operating system and the application. So bootloader is the first component in the software level to enable the hardware connections, enable the applications. So during the power on, the bootloader will be enabled. So once it is enabled, then the hard drive device drivers, the sensors or the motors, other peripherals which are connected to the hardware, that will be configured and connected, and it will start communicating with the help of APIs that is provided in the application layer. And we have the middleware. Middleware is the functionality between the drivers and the application software. And like the CAN or UART, some of the example is protocols. And application software is specifically to perform specific tasks which the embedded system is able to function, like controlling of the motor or monitoring of the temperature. Such things will be added in the part of application software. So these are the major components for the embedded software. What are the program languages required to develop the embedded software? So mainly the C programming is used. It allowed to manipulate the memory and hardware registers. And C++ is the object-oriented features. So that it is handled to the potential memory overhead. And in some cases, it is a part of a supportive and assembly language. It is mainly used for time-sensitive or hardware critical tasks. And Python, Java. So this is a higher level embedded applications. It will be used where memory and performance constraints are very less compared to the other languages. And coming to the operating systems, the RTOS. So here the RTOS required the system call. So system call is the one which enable to call the user interface and user programs. So it will be based upon the user program, user interface. The data will be sent to the hardware via the program control or IOs or the file systems or some of the communications and error management resources and auditing and security. So these are some features which will be interacted with the help of the system call. So system calls provide generally interface between the process, process and the OS. And system call help a program request service from the kernel. It is a programmatic method and only entry point for the kernel system. So kernel is an internal part of the OS. So these services are offered with the help of APIs. And what are the services of system call in operating system? So following are the services provided by the system call, where it will maintain the main memory. It helps to access the files and directories, and it will manage the file system. It will create and manage the new process, and it will maintain the IO devices handling. It provides system call protections. So what are the types of RTOS? We have a hard RTOS and soft RTOS and firm RTOS. So coming to that, how the RTOS will be developed based upon the tools. So first we need to create the development environment, whether it should be the ID, integrated development. So if we are going with the ARMX Cortex, so we can use a Keel version, and we have a IR embedded or workbench. So these are the some tool, and Eclipse ID. So this is specifically open source platform which is used for artist development. So with the help of these IDs, we are able to develop the um, artist softwares. And next we have a debugging tools. Debugging tools is specifically we have the JTAG debugger. So it is able to connect with the hardware, and with the help of ID, we are able to debug the code. And we have a trace tool. Trace style, we have to monitor the internal software variables and from framework and libraries. So FreeRTOS and JP, this is a part of a scalable RTOS for IoT and embedded system. And SIM is RTOS. It is a ARMS substract layer for RTOS development. And some of the simulation tools where we are able to monitor how the operating systems will be carried. So PEMU is the emulation hardware platform for testing, and POTUS is the simulated circuit and microcontroller. The hardware related things we are able to verify with this POTUS simulation tool. And generally, the RTOS is often used in embedded system. So we need to ensure that tasks are scheduled and completed within a necessary time constraints. So, and it is designed to process the data with the real-time data. With the on, it will be responded on time. It is a crucial for system where timing is a critical. So, such as automotive braking system or industrial automation or aerospace applications. So these are very essential, and it should give accurate and within response time. And the popular RTOS includes FreeRTOS. So it will be lightweight and widely used in microcontrollers based on the system. And we have VxWorks. Mostly the RTOS, it is a highly reliable system like aerospace and defense it is used. And we have a ThreadX used in system, require multitasking and real-time performance. So these are the popular RTOS softwares. So it will be designed to perform specific tasks. Mainly, the task managing is a important in the RTOS. The dynamic memory allocation or inter-task communication and synchronization and timers and device communication of the IOs. It will take the priority. And apart from that, there are some task related activity, it will be concerned. So the device drivers related to the Wi-Fi and the Bluetooth. So the scheduling of the task within the resource, like handling of the files on time, it will be scheduled. Based upon the schedule time, the files will be activated or closing. And every task, it have some part of semaphores, event flag, and mutex, and message queue, and time delay or timeout will be handled in the RTOS. So we need to understand about all those. This was the key features of RTOS. The first step is about the determination. So the determination will ensure that the behavior of the task, how the criticality will be handled. And the task scheduling is a preemptive. It have a preemptive scheduling. It will prioritize the task based upon the urgency, and we have a cooperative scheduling. It depends upon how the input is able to control independently. And the multitasking is executing the multiple tasks simultaneously. And it will be splitting or it will be taking the priority, how that can be multitask will be handling. And inter-task communication. So inter-task communication, we had to have a semaphore, mutex, and message queue. So these are the part of inter communication. Usually it have. So the data which you are able to send, it will be sent one after another, and one data will be scheduled, the other wait. And so one is one should be locked if other is not utilized. So it is a part of some inter-task communication data, how it able to handle the task at the different times. And we have a interrupt handling, like interrupt handling, if any hardware or software interrupts is triggered, that how that event should be taking the responsibility to updating such data. So that is a part of interrupt handling. And the advantages and disadvantages of our autos. Advantages of autos is high reliable and predictability and efficiency resource utilization and scalable for complex systems. And disadvantages of autos is it increases the complexity and the cost. And moreover, it will be the continuous process where to add more functions and more variables to enable the schedulings, and some extent the security is the other one where majority should be taken care. And example of others application like automotive system, airbag control system, advanced driver assistance system, ADAS, and electric power steering, medical devices like pacemaker and infusion pumps, MRI and ultrasound system, aerospace and defense like flight control system, missile guidance system, and satellite systems, and industrial automation like programmable logic control PLCs and robotic system, SCADA system. And apart from that, telecommunication, we have a base station control, a warp system, and consumer electronics. We have a smartphones and wearables and gaming consoles. And we have a networking, routers and switches, and firewall system, transportation, autonomous vehicles, railway signaling system, security system wise video surveillance system and access control system, and home automation like smart thermostats and voice assist. So those are the examples of the autos of hardware which essentially used in many areas of embedded systems. And next will be the non-autos, so non-real-time operating system. It is a general purpose operating system. It doesn't require any strict process to be followed. Generally, it will be acted without any time constraints. Mainly, the non-routers also called as a bare metal system. So mostly without any operating system, we are able to operate. So here the task or the activity will be executed sequentially and within the loop. So commonly used in very less complex application. So large application, it cannot be accessed, and they are typically used in a non-critical application. So example of non-autos, we can say as a Linux, often used in automotive information system and development due to the rich set of features and supports the various hardware. And next will be a part of Windows. Windows will be used in the laptops or the tabs. So it is also a one part of non-autos where real-time operation is not much critical. And the development of this are non-autos based upon the some of the IDs. We can Adreno ID, Platform IO, MPL ID can be used, and with the help of some debugger tools, we are able to flash and debug the code, that is MPLab and SPLink and logical analyzer. So with the help of some MICRO and SPA protocols, and the framework and libraries, AVIC libraries and Arduino framework, embed OS. So these are part of the framework or the libraries that is supported, and simulation tools like Proteus and Tinkercad. So these are some open OS platforms where the IDs uh, for those IDs, we are able to develop the code with the help of non-OS, and some part of processor or the controllers. It's not much required the non-autos. What are the categories of non-autos? So there is no task scheduling. So task executed how we define in a sequence. it will be single execution. So mostly the single task will be executed on time and by using the polling mechanism. So here the minimum resource usage, so like the hardware complexity is very less, so that the utilization of power also very less, and the memory constraint system. So examples of non-autos application, desktops and laptops, like we are able to run our general purpose applications like web browsers or the Word document or media player, such thing. Server systems, web servers or database servers or file servers that we are able to handle the request without any strict timing constraints. And mobile phones like operating system like Android or iOS are managing apps without any critical timing requirement. And consumer electronics like smart TVs or game consoles or home entertainment system, the non-critical, non-time critical functions. And office equipments like printers, copy, and the fax machines. So, and some of the real-time behavior, it's not much needed, where it will be delayed or it can be responded some. And cloud computing and automated testing and simulation and data analyzer. So those are some part of non RTOS application it where we are able to operate our embedded software. So the disadvantages and disadvantages of non-autos, it is a simple to design and it will low cost compared to the autos and requires less processing power and memory and easy to develop and debug. Disadvantages is there is no multitasking capability and we are able to, it is a less suited for the time critical or the complex application. So what are the applications of RTOS and non-RTOS in embedded system? RTOS applications like automotive, ADAS, BCM, and ABS system, medical devices like ventilator or infusion pumps, robotic and industrial automation, telecom communications that can be used. And non-RTOS applications we can use in consumer electronics, simple home automation systems, and basic control systems in the industrial missions. So autos is the complexity and time scheduling. It will be respond on time during the schedule where it can handle multiple tasks at a time. And non-autos, it will be handle one task at a time, and it will be less complexity will be very less. How we are developing this constraint, choosing how we need to choose the autos. So the simple require is multitasking or the real-time response. How periodic is crucial, and the hardware that able to support the additional overhead or not. So that should be chosen. And choosing of the non-autos, the application is simple and doesn't require any multitasking. The cost and power supplies are key constraints, and time requirements are not critical. So what are the examples of non-artist and artist? So example, if you take the smart home controller, so the objective is real-time control of HVAC, air ventilation, air control, and lighting and security. We can consider as a main objective. And tools here use the free artist for multitasking, and the controller we use ST32 for development of the software, and the design is the same, and trace analyzer to monitor the execution. So what it is, like we are able to monitor the temperature and we are able to monitor the light control with the help of the actuator. And security alert, it will send the communication data. And non-autos example, we have a digital thermometer where it will measure and display the data from the sensor. So that can be developed with the help of Arduino ID, AVR based microcontroller, and protest is similar to simulate the sensor data. And we can use the ID tool library for communication with the I2C is the protocol. So with the help of the protocol, we are able to communicate the data from the sensors to the hardware, and where it will hold the temperature sensor continuously, periodically, and it will display in the what is the temperature value that is triggering. So those are the major two examples for artists and